We're going to start this one with number 26, which is our inverse and direct variation story problems. So, reading the problem. A person swims underwater. The pressure of his ears varies directly. So the pressure varies directly means that it's going to be K times a number with the depth at which they're swimming. Okay, so it's saying write an equation if the pressure is 4.3, we don't know our K value, and our depth is 10 feet. So we have to solve for K, just dividing this by 10. So that's going to make 0.43 be our K value. So then we need to go back through and solve what it's asking us for. It's saying find the pressure, what is P, when the depth is at 60 feet. So I'm going to take 0.43 and multiply it by 60, which is going to give me a pressure of 25.8. I believe it's PSI. Okay, so 27 is going to be the same type of thing. It says when air is pumped into a tire, the pressure required varies inversely. So the pressure is going to be inverse, so it's K over something with the volume of the air. So if the pressure is 30 pounds, we don't know our K value, when the volume is 140 feet, so we have to find K. We're going to multiply that over to the other side. So our K value is going to equal 4,200. Well, then it wants to know, in the next case, find the pressure. So I want to know, what does P equal when the volume is 100. Okay, so the pressure on this then, when you solve this, is just going to be 42. Is kind of a tricky worded question, so just read carefully on this one. The number of students varied jointly. So students varied jointly means K times something, jointly with the number of teachers, and then the administrators squared. When I first read it, I thought it was the combined teachers and administrators squared, but it's teachers and then the administrators squared. So the first one says 1,000 students, K value. The teachers is 5, and the administrators is 2. Well, 2 squared is 4, so I'm going to go ahead and put that together. So then I get 1,000 is equal to 20K. So that means that my K value is going to be 50 when I divide that to the other side. So then it wants to know the next part is how many students. So my K value is going to be 50. Then 8 teachers and 1 administrator. Well, 1 squared is 1. So it's 50 times 8 times 1, so the students is going to be 400 for that. 29. Horses varied jointly. So horses varied is horses equals. Jointly is K times the goats, jointly with goats, and inversely as pigs squared. Okay, so right now the barnyard has 5 horses. I don't know my K value. There are 2 goats and 4 pigs. Well, 4 squared is 16. So then that is going to give me a K value of 40. So then I can go ahead and plug that back in. The next one says, how many goats are there? So I'm looking for goats when there are 6 pigs and 10 horses. So 10 equals 40 times G over pigs. There are 6 pigs, so that's going to give me 36. Okay, so when I multiply this to the other side, I get 360 equals 40G. So the goats, there are 9 of them. Number 30, y varies directly. So y equals k times, then the square root of x, and inversely as z. So then it says when y is 10, I don't know my k value yet, the square root of 9 over 12. Because that's our z value. So the square root, I'm going to multiply this to the other side, and then the square root is 3. So my k value on this is 40. So then I have to put this back in for the next part of this. So it says find y. So I need to know what y equals. My k value is 40. My x, it tells me, is 16. So the square root of 16. And my z value is 10. So 40 times 4 divided by 10. Well, 40 times 4 is 160. So that's going to give me a y value of 16. 31 wants us to graph these functions. So then you need lots of parts to this. I'm going to try and make this one bigger because there is a bunch of parts to it. Okay, so you need your asymptotes on this. So you know that, and your x and y intercepts also. So you know that the denominator is going to push you left and right. So at x equals -2, and then at y equals -2. Okay, so from here, I want to find intercepts that go along with this. So I need to find my x and y intercept. So remember that when you're finding your x-intercept, this is the harder one, that your y value is equal to 0. Okay, so I say 0 equals -3 over x plus 2 minus 2. Move the 2 to the other side, -3 over x plus 2. I can flip-flop, -3 halves, and then subtract 2. So -3 halves is really -1.5, and subtract 2 more. So x is really -3.5. So on the x-axis, I'm at -3.5. So when I reflect this, where these intersect, I'm going 1, 2, and down 1 and a little. So I'm going to go right 1, 2, and up 1 and a little. Note that these are going to be in quadrants 2 and 4 because of the negative sign. So now I need my y-intercept, meaning that x is going to equal to 0. So I get y equals -3 over 0 plus 2 minus 2. -3 over 2 minus 2. So -1.5 minus 2. The y value is also going to be -3.5, which is coincidental. That's not a usual thing. So I went up 2 and over 1 and a little. So I'm going to go down 2 and over 1 and a little. So that's enough so that I can graph my points. (32) is going to be the same sort of thing on this. So for my asymptotes that I have on here, my x-asymptote is going to be at 0. So on the x-axis equaling 0, x is here, so the 0's that. And then my y-asymptote is going to be at -1. Okay, so then what that means is when I'm trying to find a y-intercept, well, let's do our x-intercept first. Our x-intercept is going to be when y equals 0. So I'm plugging 0 in for y. So I have 0 equals 4 over x minus 1. Add 1 to the other side, I get 4 over x. Flip-flop, and I get x equals 4 over 1. So x is 4. Okay, so for x to be 4, on the x-axis at 4. This is over 4 and up 1, so I'm going to go back 4 and down 1. So then I'm going to do my y-intercept. Well, I can't hit the y-axis, okay, because of the asymptote. So there is none there. But instead, I should probably try and find another point. So maybe try and plug in x equals 1, because I know that it's going to hit there. So that's going to give me 4 over 1 minus 1. 4 minus 1 is 3. So at 1, this is the ordered pair, 1, 3. Over 1 and up 3. So I'm going back 1 and down 3 in order to reflect that. And now I can make a much better representation of this graph.